Welcome to the Valohai stream again. My name is Eero Laaksonen. And
And I'm Arni Koskela. I was thinking you would go for like you're the CEO and I'm the CTO thing, but whatever. Yeah.
yes, I'm the
So
CEO,
yeah.
you're the CTO. You're
Yes.
correct. Uh, hey, last week we talked a lot about machine vision, about the classical way of doing machine vision, did some object detection uh, with YOLO, probably the most used machine vision model out there. And today we're gonna continue on the theme, but we're gonna be looking more on like how does this machine vision work in transformers? What are the modern new tools in machine vision? But before that, I think let's Arnie. I think you had a nice, interesting project that I wanted to share, or I wanted
Yeah.
to ask more about. You were in Japan a few weeks back.
Yes, I was in Japan, in fact. By the way, how do you know someone's been in Japan?
They will
Don't
tell
worry,
you
they will
about
tell you. Yeah. So anyway, I had this idea of making a supercut sort of video for Instagram of like some of the 1,500 photos we took, and I figured, well, we have vision LLMs, so why not like make an LLM grade those photos, and then let's have an algorithm pick the images that we want to put in a reel and so on. Well, it didn't go fully automated actually, because turns out the model didn't know exactly about all the places we wanted to show in a reel, but still there was an interesting pipeline going through Gemini Flash to rate each photo on a like scale from like technical quality and emotional value and so on, and also it classified whether the images were junk or not. And eventually, well, 1,500 photos cost about 10 euros to rank through Gemini. And then there was an additional local embedding step that would take all of these images and make sure that each day in the video was good quality in those axes and also as different as possible. So basically, we were maximizing the cosine distance between these embedding vectors rather than trying to find for a RAG purpose, you would try and find the closest matches, of course. But now we wanted the like variance within the prospective peaks to be as large as possible, so we wouldn't get those technically perfect and emotional sunset pictures, but we would also get like a silly photo of ramen or whatever going in there. Anyway, that was fun. And then for compositing the video, there was a pretty simple pipeline that takes those videos, does a little Ken Burns style slide and zoom effect on them, and pipes those images through to Pillow. Let me see actually if I have, yeah. Here we go. So render, this is all actually mostly coded by Claude, so I just prompted a lot. Anyway, it does a text overlay and fades images between each other. And then I was like, okay, 60 FPS is good, like slightly faster than real time. That's fine, but can we make it faster? So the first thing I did was poke around Pillows. Well, actually, the first thing I did, which is the thing that you should do when you're trying to figure out why something is slow, I measured it. So I took Tracer, which is Tracer. Let me. So it's a pretty cool open source project that does timelines using Perfetto, which is Google's performance analysis thing. It's really nice as well for many purposes. Like if you're doing low level Android system performance analysis, this is apparently the tool they use. But system wide profile for Linux and Android. But it can also do app tracing, and Tracer plugs that into Python. So
Arni, can I say that most people, when they want to make a video of their holiday photos, their first idea is not to use a professional
I know,
profiler to
I know,
optimize
but
the
I'm
generation speed from 60 FPS up for a single shot project.
Yeah, but I'm impatient that there were like there's lots of knobs for the generation project. So if I look at JPN 26 Kuvat here and do UV supercut render help.
Can you make it a bit larger?
Yes,
Yeah.
yes, sure. So like there's all of these knobs that I might want to tweak, and then I want to iterate quicker on the video. If I wanted to iterate quicker on this video by making it by hand in Premiere or DaVinci Resolve or whatever, I would have actually given up because I don't have the patience to do this manually. So yes, it was faster to A, do this by machine, and B, to start optimizing the generation speed as well. Anyway, but yeah, so I ran the render through Vistracer, and I get something like this. This is actually a slightly optimized version already, because earlier we were kind of like staggering between generating frames and loading the images. So now we have a couple of worker threads here that load images into a cache, because we have enough memory to keep, I don't know, 100 images at a time in memory. But we have two threads that load images into memory. So the generation thread that will then feed raw video to FFmpeg for encoding has what it needs to work with immediately. But anyway, one of the things that made this part quicker was, if we zoom in over here, zoom, yes. So by default, Pillow, which is the Python imaging library, has a knob called max block, which basically tells imaging to only like decode, for instance, decode or encode a small chunk of data at a time. So basically, if that was unbounded, you would easily be able to paint yourself into a situation where you get a DOS by allocating too much. So the default is very conservative. It's 64K, which it's tiny, but it's also not a knob that generally you even know about. I didn't remember it. I had seen it earlier sometime back in the day, but I forgot about it. But just tuning it to 16 megabytes made this bit a lot faster, because now we weren't like decoding only 64 kilobytes of a 10 megabyte JPEG at a time, but we just could read all of it into memory, decode it in one go, and just do that. And same here, where we are writing the raw bytes from the RGB buffer to FFmpeg. This used to be like tiny little encode chunks, and making that a single encode that is written in a single buffer. And crucially, it saved us from allocations, because what actually happens if I move on over somewhere here to encode, oh no, that one. This one? No, still not that one. I can't find it. But anyway, so what Pillow was doing is calling the image encoder encode function for that 64 kilobyte chunk, putting those chunks in a Python list, and then calling join on the list. If there is only a single item in the list, Python itself has an optimization. It doesn't do a copy. So basically, we saved a full copy, so double the memory basically, and of course performance by a single line. So like just adding, when you have a project where you you can lift max block to something bigger than 64K, then do that. But that wasn't like, that was the second thing that kind of popped to me, and the other one is over here. So we can see, so in my supercut video, we have like an image, and then it fades to another image, and to do a blend between images, if you're not running on a GPU, and we're not, this is all CPU, you will need to blend between the frames. So basically, calculating a crossfade, so an alpha blend. I mean, the math is simple, but anyway. But I was wondering how can this take they take 5 milliseconds? I mean, that's 5 milliseconds. That's like, if this was a
It's forever
game,
time.
yeah. I mean, if this was a game that was supposed to run at 60 FPS, that would be 1/3 of your frame budget. So
Yep.
yeah. So anyway, I took a look, and so all of the low level stuff in Pillow is in C. And this is basically, if we look at the git blame for this file, the history here is probably actually pretty correct. So no one actually really touched this file after 1996. This commit from 2010 is when Pill, the Python imaging library, was forked into Pillow.
Can you
Uh,
zoom in a bit again?
yeah, I can try. Yeah, so history says created in 1996, simplified blend expression, fixed the bug, and then the commit that's like most of the file. I'm just going to zoom out so you can see it's most of the file over here. Is the single commit that took the squashed SVN history of Pill and turned it into Pillow when Pill was no longer being maintained. But yeah, so we can basically, I actually tried to splice in some of the SVN history so I could see more, but I didn't want to go too far down that rabbit hole. So I'm just gonna give it, it's old. Anyway,
Yeah, I still just barely remember the days of Bill still being.
yeah, Pill and Pillow and so on. Yeah, yeah, and back in those bad old days, you had to you had to trust the pre-built Pill you could get from some random site, that you had to hope that they were built against your Windows Python version and so on. But yeah, it's so the function is pretty simple. Even if you're not a C programmer, you can probably follow. So basically, if alpha is 0, then we want the first image, no need to do any math. If alpha is 1.0, then we want the second image and no need to do any math. Otherwise, we allocate a new image without cleaning it up. So basically, it's random pixels, but since we're going to pass through all of them, it's fine. We don't need to allocate, we don't need to clear them. If that fails, then fail. And then there's a case for extrapolation, which is a bit weird, but it's there. I mean, mathematically makes sense. Image-wise, I'm not sure it makes sense. But anyway, but yeah, this is the case we're interested in. So, I mean, looks pretty clean, right? So loop over the rows, take a pointer to each row, loop over the line size, and then cast to floats and do the alpha blending, and then cast back to 8-bit integers.
Yep.
But yeah, there's a couple of things here that are actually make it impossible for a C compiler, which are pretty smart these days, to optimize this perfectly or at all, or well, perfectly. So a couple of things. So the first thing, we know that Y size of the image, the input image, it can't change over this loop, right? But there's no guarantee for the compiler that this doesn't change somewhere here, or that another thread might change it or whatever. Same for this. Line size will always be constant over this loop. So, and secondly, which was a more interesting thing, I had forgotten about it, and yeah, I consulted Claude and Codex with these, is that there's a keyword called restrict in modern C, which basically says that I pinky swear and promise that there's no way that these pointers can overlap with each other. So I guarantee that these will be unique. And for this case, it matters for like copying operations where you could, and in fact, that's what ends up happening in the optimized version. You can end up doing an optimization where you copy like 4 or more, or do like 4 or 8 or whatever operations at a time with like with SIMD, so single instruction, multiple data operations. But you also can't really apply those unless you know that this will be constant, because then you would have to have a really complex mechanism of figuring out if you can have like a 4, 4, 4, and then 3 pixels or whatever is the size of your image.
Yeah.
So if this was not a constant over this loop, then that optimization can't be applied. And restrict also, not having the guarantee of non-aliased pointers means that it can't optimize for using those copy operations that it could otherwise. So basically, if I go over here, pillow, and the pillow, not pillow puff, it was different. If I go over here and switch branches to faster blend, there's a couple of comments so people know what's going on. So we hosted these up to Y size and line size, and also noted here why these are restrict safe. So because actually having alias pointers when you are pinky swearing they are restrict is undefined behavior, and we don't want undefined behavior in our C code. So that's why we have this comment here for human readers and future LLMs. So when they are reading this code and trying to be even more clever by, I don't know, doing something like, well, there's not much more cleverness here without doing actual SIMD. But anyway, it's good. Similarly to like how Rust programmers tend to annotate code that's unsafe, technically unsafe, but then they have a comment that says this is fine because we know this invariant that the compiler can't. So here the invariant is that, yep, we are only reading for im in, im, and we're only writing to im out, and we know that these can't overlap because we had this additional check here added as well. So if the images are the same image, then again, nothing to do, just return one of them. It's the same image, or return a copy of it because the
any blend level will be just the same.
Yeah. So this, let's switch back to the here, and let me switch back to main, and maybe pip install. No, that one. No, not that one. Yeah. So let's rebuild it and then do a not the compare but PyTest benchmark autosave bench blend. Actually, I'm just gonna remove the current benchmarks, and yeah. So now we're benchmarking on main. We are getting 99 blends per second of a 2K image. It's okay, sure. And let's switch to faster blend, rebuild the thing, and rerun the benchmark, and we get 400 blends per second. So it's not a bad improvement given the changed number of lines. It was like this much. So
that's a pretty impressive optimization.
yeah.
What do you think now that coding agents are getting better and better? What's your intuition on how much we can improve? Because there's like obviously Pillow is a hugely popular image library, right?
Yeah.
I don't know how you can probably get us some stats on how much. Uh,
It's downloaded 165 times per second.
yeah, so so uh, I
Yeah.
mean not everybody is using Blend, right? But it's a pretty common a common operation still.
Yeah.
Um, what is it? Last 24 hours we're doing 15 million point
Yep.
6 million downloads.
Yep.
So like just this simple optimization, if we could automate a lot of this for the most used libraries, I think like we have a lot of free compute coming from just the optimization of a lot of these older libraries that haven't
Yep.
been truly gone through.
Yep. And there's like one of the I'm pretty sure Pepe has like, yeah. So Boto 3 and Boto Core are the AWS libraries.
Yep.
I have a PR that's been pending on Boto 3 or Boto Core, I can't remember which one, that simplifies the timestamp parsing that it uses to be a lot faster. It's been there waiting for someone to review it for like 3 years now. I really hope someone from AWS finds this video and maybe takes a look at it, because I've been thinking like if that gets merged, then I won't have to think about my my carbon offsets from going to Japan once a year, because like all of the cycles, like we are looking at a package that is downloaded 1,000 times a second,
Yeah.
and the number of timestamps that are being parsed from AWS responses per second is probably a lot more.
Yep.
The globe. So if that can be made quicker, and it's I don't remember the percentage quicker it was, but it was seriously quicker. Yeah, we would save a lot of cycles
Uh,
with like tiny little things.
yeah, I hear that one of the issues uh, that open source maintainers are having is that uh, like just the sheer time required um, to validate all the incoming PRs
Yeah,
takes so much time that it's next to impossible to keep up with, and especially now at the age of coding agents, people have been pushing a lot of crap into to.
sure. Yeah, that's a big problem as well, and it's unfortunate, um, because there's obviously like you want to have your name in the lights, as it were, and to say that, hey, I contributed to this project and so on, and then it might get you a job opening or whatever. But if it's just actually your coding agent doing the contribution, then is it worth it? I don't know.
Yeah, and especially
Yeah,
if it's not that significant, or even in some cases you don't personally understand what you're
yeah,
committing,
exactly. Yeah,
and it can get a bit hairy. But I think that um, larger projects are starting to implement these um, agents based um, pre-checks where like your PRs are going to an agent uh, to first check for quality. So then it reduces the amount of crap coming in all of a sudden. So I think that's
there is
potentially a way to combat it.
yeah, yeah. There are agent based checks, and then there are projects like Vouch from, I think, Mitchell Hashimoto, which basically gives you an allow list of contributors, uh, which is, I think, it's pretty heavy handed. Um, but I'm not sure if it can be helped in any way. But yeah, I can imagine like large prominent projects get a lot of slop PRs, and there's not much you can do about it. And then unfortunately, that means that some of the actual good PRs, like of course all of my PRs, get
Obviously.
hidden between in that all of that noise. I think actually there was a good example on pre-commit. Let me go to pull requests and closed. Uh, so so yeah, I think there was some agent that looked for, or some people's agents were looking for the signal for this bug and figured out they could fix it. And yeah, then you have PRs like this that are just closed.
Yeah.
Yeah, but like basically the same thing from three different people. And I
Yeah.
think there's maybe one. No, there's no open one for it anymore, at least. Yeah, I think if I did this, there's, yeah, one, two, three, four. Oh yeah, there were more.
Oh
Yeah,
no.
yeah.
Oh no. Okay.
I like
Hey,
this symbol, ship it and pray. Yeah, but yeah,
that's
that's
definitely a real person.
absolutely, yeah.
Can we check your Boto 3 commit in case this video gets traction?
Absolutely. Where we are. It wasn't this one. This was unrelated, but also got eventually closed. But let me see. Yes, from 2023. So, yep, basically mean OPS improvement for parsing timestamps of 16x. But yeah,
Okay. Okay.
yeah,
So we're requesting for a review for this.
yes, pulse.
All right. Hey, let's get to the topic of the day.
Sure.
Moving on to machine vision, we wanted to check out Marlin 2B today. So like I said last time we talked about uh, time we talked about YOLO, the
Hmm.
classical model, classical machine vision model, probably the most used. I think it's pretty easy to say the most used machine vision model up to date. And then today we're gonna be looking at more modern transformers based. Okay, yeah, you're looking at it. So we're
3 times per second, so it's not quite as popular as Pillow,
yep,
but still 3 times per second. It's not bad.
yep. So we're gonna be looking at some of the new kids on the block and
Hmm.
what are these good for? What are people using transformer uh, based machine vision models for? Marlin 2B got a lot of action in the past few weeks after coming out. So Arni, can you tell us a bit about what is Marlin 2B?
Sure. So it's a small model, 2 billion parameters only, and it's to extract what is happening in a video and when. Um, it doesn't do like object detection, bounding boxes, or anything, or object counting like we did last time with Ultralytics. Um, but it uses a Quen-based model, so you can see here in the model tree, it's a fine-tuned version of Quen. To find to give you a text representation of what is happening in a video and when that is happening. It can also answer questions like when is there a, let's say, dog in a video, or a, I think the example here was gunshot or whatever. But yeah, and it's Apache licensed, so you can run it locally. The company behind it, they will help you fine tune the model for your own purposes, probably for some money. But for now, we're just using the model that they are giving us for free. But yeah, basically it runs on Hugging Face's Transformers platform. Nothing very special about it. Of course, we don't know the secret sauce that went into training it, but that's how open weights works.
Yeah, and
Yeah.
did
Yeah.
did they expose any fine tuning API for this or?
So
Uh,
what I saw, well, yeah, there's a contact us link that links to someone on letsnemo.com. So I guess they have, ah, okay. I get why they have a vision model. So they have a no code tool for E2E testing. So they need a model that can figure out when something is happening in a video of a E2E test. So
yeah,
makes sense. So basically they have a tool, and they needed some infra for it, and they built the infra and they released part of the infra. Cool.
yeah.
Yeah.
So um, so this is pretty easy to set up. It runs on the pretty classic transformers stack,
Yep.
just like any other LLM, right?
Pretty much, yeah. So it wasn't anything exotic about it. I could run it on my MacBook at a decent speed. You can run it at a much better speed with a GPU that has actual memory bandwidth. So yeah, one of the bottlenecks of Apple Silicon is that even if we have like 64 gigabytes of unified memory, it's not as fast as HBM5 memory would be on an actual GPU. But that's what you get for having a supercomputer that you can lug around, and yeah,
You can't get everything.
yeah.
uh,
And you just have to have that famous patience I was talking about earlier to spend 40 seconds capturing a 10-second video. But it works, and that's the main thing.
yeah, and I think also the fact that you can test it locally
Yep,
makes developing on this a lot easier
totally.
if you're
Yeah,
building something. If it was only possible on like multi GPU
yeah,
VMs on the cloud, then it's like developing becomes a lot more difficult.
yep.
Um, okay, so how would one set this up?
So they have, as usual, they have a quick start over here. So basically, you import torch, you import transformers, then you tell it to load some code from the internet. So this is the Hugging Face way of running a model quickly. So then you call caption on the object that you get.
Okay.
But this is all, yes, it's remote code, but it's also all open code here. So in the files and versions tab, it's basically what happens when you do that is finds the config JSON, figures out the model configuration from here, and then this bit lets the code from before know that it should actually load modeling Marlin, which is the Python file here. So long as you can read this file and figure out if it's doing anything nefarious, it should be fine. But still, for our purposes, I opted to download the full repo from here and just use a local version of that file as well. And that's also what you would probably want to do in production, because in the unlikely case that Hugging Face goes down for a blip or forever or for a week or whatever, then you would probably wouldn't want your production to go down with Hugging Face. So
yeah, especially since a lot of the use cases for these are also on the edge, right? So
yeah,
then you would anyways need a way to deploy this completely remotely.
yeah.
So basically, the code will download the model from Hugging Face if you don't have it already, and
Yep,
then set it up.
yep.
So let's do that.
Yeah. So as per usual for machine learning projects, the requirements that you need are somewhere over here, and not in a very easy to use format. But I've done this whole thing here, and they are in my PyProject YAML, TOML, with all of the other requirements there were actually not mentioned there, but that's how it goes.
Can you zoom in a little bit?
Absolutely. So yeah,
Yes.
we have Hugging Faces Accelerate, we have libav, which does video transformations, we have Pillow, which we touched upon just now, we have Qwen VL Utils, which is from the Qwen Alibaba team. It does basically decimation of video into chunks that the Qwen vision model understands. We have Rich, which I wanted for rich output. We have Torch, which is, well, Torch, Torch already. We have Torch codec support, we have Torch vision support, and then we have transformers. Of course, this expands to a lot more transient dependencies, but yeah, not that bad. Yeah.
Nice.
Yeah.
So then,
yeah.
if you wanna set it up, and then maybe let's look at the Marlin API. Like, what does the model expose?
Yeah. So I'm just gonna, let's see if I can remember this from the top of my head. So we have the modeling Marlin thing we downloaded earlier, so it's over here. I'm just gonna do, let's say, Marlin equals modeling Marlin, modeling Marlin dot that one, and we're gonna do from pre-trained, and we're gonna tell it the directory over here. We want to cast it to torch.bfloat16, which is what we want here, and we're gonna tell it is it MPS 0 or is it 0 MPS? I can never remember. We'll see how that goes. Just actually probably gonna be able to run it here. No, not that env. Yes, actually that env. Yeah.
And if you can zoom in the terminal too.
Yeah, I can again try. Yep. Okay, so it loaded weights and says hello, like I wanted. Great. So the API, as we saw here, is pretty simple. They have a Marlin.caption function. So I'm just going to do result equals Marlin.caption. And we have a video I prepared earlier. I'm just going to copy the name of it from here. Did I mention I went to Japan? So this video is from Japan. I'm gonna show it in a bit. I'm just gonna do a little thing here because from pre-trained has a bad type hint. So just wanted to type into PyCharm here that we get the same class, because technically from pre-trained could result in something different, and that's, yeah. It's actually, it should probably, yeah, okay, that's a correct pipe hint, but it's not perfectly correct. Anyway, it's fine. Now we're just telling PyCharm that, we're getting this class. Then I'm just gonna do reach.print result. Pretty good, yeah. And now if we run this, zoom in again. So there's a couple of log messages.
I can't wait to learn what's in the video from the model.
We can see again from my trusty GPU stats meter that something is happening, actually from the CPU meter as well, which is kind of telling me that it's not doing much on the GPU, but a lot on the CPU. So we'll see if this is much slower than when we were rehearsing this. I think my device map might be incorrect. I'm gonna quickly peek into my baked earlier thing to see. No, it needed to be empty string to MPS. So I'm just gonna do that. Love this sort of API. Like obvious, yeah.
Mystery API.
Yep. Yeah, don't get me wrong, I do love what Hugging Face is doing for a lot of things, but sometimes you get this API design that's obviously grown over time, let's say. Yeah, now we are getting 99% out of our GPU. So yep, my laboratory here is heating up. I can hear the coils whine and the fans spin. Actually, I can't hear anything yet. Are we, where do I see the temperature? Battery temperature is only at 30 Celsius, so we're good.
It's not too bad yet.
Yeah. Yeah, but certainly something is happening on GPU now, because CPU is like not doing much, and GPU is.
So while we're doing that, can we look at the API calls that we have at our disposal? So we just got it.
Yep. So we got a JSON Python dictionary object that has caption, scene, and events. So caption is basically the whole output from the LLM, and scene is split out of it, and events are split out of it. So a narrow, dim lit alleyway, night lake in a Japanese residential area. The ground is paved with large concrete slabs, metal drainage grate, wooden bench or platform with a small bowl and some items resting on it. Walls are a mix of pale yellow and white, with dark window frames and architectural details. Ginger and white cat is the primary subject, initially walking away from the camera down the length of the alley. The lighting is artificial, casting long shadows against the walls and the cat silhouette. Then we get this structured list of events happening. So from 0 to 11, the cat walks down the center of the alley. From 11 to 13, the cat slows down and turns towards the left wall. And then, it's against the wall looking around. So if we actually show the video here, I'm gonna just move it over the correct display as well and zoom it down so it doesn't. I'm gonna try and zoom it down anyway. Okay, this is fine. Yeah. So so one of the ryokans we stayed at in Odawara, they had this cat that was part of the furniture, as it were. So you couldn't let the cat in, but you could pet it. But yeah. So yes, from 0 to 11 seconds. Let me just. Yep. Cat is walking. The cat still continues to walk. Then we see the cat turn and slow down. And then it's, well, you could say it's sitting against the wall. Maybe the resolution of the video is for the VLM is not good enough for it to figure out it wasn't against the wall, but it's fine for our purposes.
Yeah.
Fine for a vision model running on a laptop and doing this in 40 seconds.
I think it's pretty impressive for the amount of detail and size of model speed and how fast it was on.
And probably on like NVIDIA hardware, it would probably be a lot faster as well, because this is probably tuned on CUDA anyway. So
yeah, I should probably try on my laptop here.
Yeah, and I mean, because this is really This didn't have any exotic modules like, for instance, back in the day, Stable Diffusion used to do a lot of weird like research modules, and you would need like X-formers instead of transformers and whatever. This is really vanilla torch and transformers.
Yeah. Okay. But looking at that, what are the uh, uh, other operations we can run?
Yeah, so there was caption mode, which we saw here. Then we have find mode. So basically, you are prompting the LLM to figure out where something happens. Uh, so yeah, if we just do this, I'm just gonna comment this out and paste that in and do this. Um, cat stops walking.
Yeah.
So we should get something like 12 seconds, 30 seconds. And we're just also going to want to print this. Otherwise, we're going to be sad after 40 seconds. So
Just
again,
did
let's go.
everything for nothing.
Yes. This is perhaps one of the places where I would be okay using a notebook sort of thing to keep the model loaded into memory.
Yeah, that would definitely makes sense. Um,
But then moving to anything production like, then I would toss the notebook. But again, these days you could just tell your LLM to take this notebook and squeeze a command line tool out of it.
yeah, that's what our customers are starting to do more and more. Like
Yeah,
you iterate in a very human sensible format in notebooks, and then you use the Valahai uh, tooling to tool calling to
yeah,
just tell Claude basically or any coding agent that
yeah,
take this notebook pipeline and turn it into production pipelines, and
yeah,
most of the time it can just ace it in a single go.
sure. Yeah, Drusen did a really good job with the Valahai skills repo. It's
Yeah.
super nice to just be able to do that. Yeah, we got 10 to 11.5. So let's see. I'm gonna do MPV start equals 10 video this, and then it's going to be on the wrong screen again. Actually, I'm gonna do. I think we can do. Yes. So now it's paused to begin with, which makes this a bit easier. Then I'm gonna try and figure out which gesture I did last time to get it. That's fine. Yeah. So starting at 10, and the cat stops. Yes. Looks good to me.
Seems to work.
Yep.
I mean, a pretty simple example, but still, I don't think that there have been a lot of models that can achieve uh,
No.
this before. Uh, how about other calls? Are there any
Well, I
other
mean, they
calls
are
on the
not
API?
documenting it, but there is another call called multifind, which locates more than one event of the same type. So where find stops at the first event, it finds multifind slices the thing, slices the video into multiple chunks, and keeps finding more events. And I imagine, because this again, it's an LLM, you could probably just try and give it another prompt to like find all of the cat events or whatever, but then you would probably also need to parse the result by hand,
Mm.
because I think that Nemo Station or Nemo Labs have tuned this for these two prompts that they have here, and kind of the the admonitions over here at the comments say do not edit and must match exactly, which I can imagine. So they've come up with these simple prompts. Um, but yeah, let's actually
So these are
do a
the prompts
little
that they are using on
for
the back end.
the describe. It's provide a special description of this clip, followed by time range events. For each event, give the time range a start, end, and short description. And for, I'm not sure what they call it, grounding prompt template, but identify the timestamps during which event takes place. I'll put time range as from start to end. Actually, now I know why it's called grounding prompt template, because they've used this for training with human, feedback, and a human has been scrubbing the video and seeing whether it's grounded with these.
Grounded in truth, yeah.
Yeah.
Uh, uh, just to elaborate on the system prompt, so how does this specific template work? Does it replace the event in the grounding?
Yeah, so
Or
it's just a Python template.
yeah,
So if we find look over here, it's just doing template format.
yeah,
So yeah,
with your event string, right?
yeah.
Nice.
So there's where you want, if you know someone's using this model, that's where you want to do your prompt injection. So
Sure. Uh, all right, and then
but actually let's do something. I want to see, so generate video is basically what it's the underlying function that both of these call. So basically it's just doing if you've been working with LLMs or LLM APIs, this should look really familiar to you. So it's a standard format array of events or like conversation. So we are the user. We are we have some content, which is the video, and then we have the prompt. Then we apply the chat template to tokenize this to tokens, and then you know do all, you get the vector, and yeah, and actually you get a dict of stuff here because this model needs both like your usual text tensors, the text tokens, and then there's also the vision patches and so on. So you get a dict of stuff that you need to pass yourself to generate. But what I'm interested in here is let's take the so after the I'm just gonna do out decoded and just do a cheeky little print over here and then return out decoded because I'm kind of interested because I noticed we had some stuff here that strips thinking blocks and so on. So I'm kind of curious to see what the raw output from the LLM is for captioning the video. So, and also while we're at it, I will, even if they say I shouldn't do this, I'm gonna switch the prompt to, let's say, provide a special event for the time. Let's do the description must be in for each event must be in what do we do?
finish.
I don't want to do finish because this is a tiny model and it probably will screw that up royally, but let's do imperative tense. And sure, let's do that. That's fine. But yeah, I'm curious to see what the thinking blocks are and so on. This might fail royally, but only way to know is to find out.
That's what they promised.
Yeah. If they say do not edit, we will edit those.
Can we
Yeah,
zoom in on the terminal output again? I think it's gonna be
yeah, yeah.
interesting.
There was a I can't remember the model right now, but there was a interesting, really tiny transformer based or like I think it was transformer based text to speech model that was like only like a couple thousand parameters. What I did with that one was I think I like called randomized uh, all of the vector parameters a little bit, so you could get like a circuit bent effect on a text to speech model that was transformer model. That would be interesting, but you can't do that with a large model because 2 billion parameters are a bit too much to just tweak randomly. But yes, sure, it's still doing the thing. Let's see. Okay, we didn't get any thinking here. Are we stripping it before that? Parse caption. No, it should be the raw stuff. Okay, so just didn't have any thinking blocks here.
Yeah.
Yeah, and it wasn't very interesting. Okay, let's must be in flowery poetic prose. Let's see. Do we get a poetic cat? But yeah, it's an interesting model though, and
It is. I'm a bit interested in while we wait for that. How does this work? Because the model obviously needs to get everything in context.
Hmm.
So in classical LLM fashion, we understand the system prompt and then adding your user prompt. But then, how do we insert the image, the video images into this context?
Yeah, so we can poke into that a bit as well. I'm gonna do what all good debuggers do and just do print inputs over here as well. And so once we finally get the output from, no, it's
It doesn't want to do it.
no, it doesn't, obviously doesn't want to do my flowery poetic prose. Well, I mean, it's not trained to do that. That's fine. So yeah,
I
so
guess it's not very surprising for a small model that's been very
no,
heavily fine
no,
tuned for a specific output type.
no, yeah. But if we do this, so we can take a tiny look at what's happening at the template part of things. So basically, self-that processor is an instance of based on the processor config over here, which is a JSON file of transformers slash Hugging Face fashion, which has, how to configure an image processor, how to configure a video processor. So it's, and again, I'm zooming, yes. So interesting stuff here is it's decimating the video down to 2 FPS. So originally my video was probably 50 FPS and 4K. Um, so it's squeezing that down to 2 FPS, which also kind of means that the model won't be probably able to resolve like really, really fast action. Someone should probably try that out somehow. And then it is resized, and then I think hard to say what that magic number is, but anyway, it's then clipped to 16 by 16 patches, and I think there was also temporal patch size. So basically, every 2 frames of the video are being squeezed into patches of 16 by 16 pixels, and I think, are we able to see? I can't see the number of patches we get, but anyway, I think it was somewhere around 1,000 patches, 1,000 vectors per frame. So if we look at the tensor here, yes, again, yep, sure. Look at the tensor here. We're not seeing all of it, but basically, if we look at what's token this, it's IM start, and yes, sure. So it's the basic. Here starts a message token. Then we have IM end, and what we can't see here, but we do know it from our earlier tests, is that we have vision start tokens, and then we have let's see here. I think what's video pad tokens are not actually used by the model, but in this like pre-processed prompt, we get the token stream is like IM start, so message starts, it's the system prompt. Then I think we didn't actually even have a system prompt here, but we could. We had the user message starts, then we have the vision message. Oh no, wait. We had a timestamp. So basically, the model sees a real text-based timestamp. Then it sees a bunch of vectors that are from the Quen vision transformer model. Then it sees another text. Then it sees vision tokens are ending here, and again timestamp for the next, I don't know, half second, and so on and so on and so on for the full video. And then we have the user prompt after that, and that's basically how it works. So the video pad tokens that would otherwise be here in input IDs, they are being replaced by these pixel values videos patches, and those are then turned into vision tokens, kind of in the pipeline from
Okay.
that one.
So so like so there's like batches of two images that
Yep.
are one after another in kind of a
Yeah.
list, and those images
So
are
those image pairs are like, so that encodes a little bit of like motion for each moment for the model to see.
yeah. So the model is kind of looking at two following frames
Yep.
at any given time. It's not
Yep.
looking at a single frame,
Yep.
and then if I understand correctly, it's just being turned into a vector that is
Hmm.
like a very multi-dimensional vector that is that it then internally deciphers as it pleases, right?
Yeah, that's how I see it. Yep. I'm sure we can see the size of the vectors here, but yeah.
So it's like so the same model in the same prompt is taking in like text and then encoded video
Yep.
vectors, and somehow it's able to kind of then just with its internal embeddings able to decipher that into different moments and context and so on, and then
Yeah.
that
So
then gets transformed into
yeah. So
intelligent output.
yeah. So I think like the big aha thing is that you have, this is like basically the same sort of architecture you would have for just a still frame VLLM, which does the same sort of thing. It uh, turns the image you paste into like Claude or ChatGPT or whatever, that's turned into vectors with a vision transformer like this. But instead of having one of those in the prompt, you just have the sequence of timestamp this frame, this frame pair, timestamp frame pair, timestamp frame pair, and the model has been suitably fine-tuned to realize that this is video and that these things that happen in this sequence of timestamp to frame pair have a like continuity, and that's how we get like the cat and so on. So you kind of like the LLM in itself does reasoning about how the frames, which are basically just images, are related to each other based on the timestamps and its own intuition.
Mm. Given, of course, the model has to have somewhat limited context.
Hmm.
This means that there has to be some kind of limit of maximum video size, right?
Yeah. So if we look over here, I think they said, uh, I think, yeah. So demo accepts clips under 2 minutes. Well, it's actually the model that accepts uh, clips under 2 minutes. So basically, what we found out is that the model has been trained on clips up to 2 minutes. And if you paste or give it a video that's over 2 minutes, then the 2 FPS decimation gets turned into like even lower FPS. So basically, we do always want to fill in the full 2 minute context, but when we have more than 2 minutes of data, then we just slice it into like scarcer time slices.
Yeah.
So
So it
as I understand it, yep, the temporal resolution of this model falls even more if you give it a longer video.
yeah. So let's say we take a 2 hour video, it will basically take turn it into
A
2 minutes
slideshow
of
of,
video
yeah,
slideshow basically,
yeah,
and look at those one after another, and then it will be very difficult to decipher
yeah.
anything.
I would be kind of interested to see how it would do for like a full movie. I mean, could be interesting. I don't have any copyright-free full movies right here, right now, so I can't try this out. But yeah,
Yeah.
technically, as I understand, the processors in here should do that automatically.
So then one way to do this could be to split your longer video. If you want to use this for something, right? You could split the longer video into 2 minute videos, but then you again lose the total temporal context of
Yep.
that
Yeah.
that window kind of doesn't go over those 2 minutes.
Yeah. You could probably try and then hack it by like chaining the previous output into that prompt. and hope for the best. Hope that the model kind of understands that it's like it's continuing from something else, but I wouldn't count on it necessarily.
Yeah, looking at how stiff it was for the prompts and how stiffly fine tuned it was, I have a hard time seeing that it'd be very good uh,
Yeah,
at, at hacking this kind of stuff,
yeah,
right?
yeah. Something you, yeah. I mean, if you did want to do analysis over a longer video, you could of course try and like overlap those chunks, but it still wouldn't have that long context of like if you even if you did that for a movie, it wouldn't have like the context of who these characters are besides that chunk and the overlap. So
Yep.
yeah.
Hmm. So
But actually, if you could do this as an like an ensemble or tool calling experiment, so like have a thing slice those videos and get all of these like these timestamped slices and then have a smarter, larger LLM stitch those up into a larger understanding. But
that could
yeah,
definitely work.
yeah.
Uh,
So yeah,
so I think we're coming to the end of our stream now, but maybe to pull it all together, last time we looked at the more like classical approaches for machine vision, um, using YOLO for more like kind of real-time object detection type of use cases, and then these new transformer type machine vision models that are starting to pop up and are actually getting to a usable level.
hmm
Um, Not quite same use cases. You shouldn't be using this for something like we did last time, like a car object detection from live stream
yeah,
video. This would never work for that. At least not at this point. Maybe we see these models get really good over the next few years, but right now it's kind of the early days for this, and they are more for complicated context understanding, searching for complicated events in a video stream. For that kind of stuff, I don't think that there's anything quite as interesting as this.
yeah. Mm, one thing I could see like well, my supercut project was using Gemini because my vacation photos are on Google Photos anyway, so I trust Gemini or Google with that data. But if you wanted to do this for your like local video collection or your kids' videos or whatever to see where a kid is playing with the hammer toy or whatever, then I mean this is here. You can run it right now. You could get a JSON file out of it, and you can grep a JSON file, and otherwise you might have your like old your that collection of VHSs you've digitized or your dad has digitized and whatever you have, that external hard drive somewhere and you don't know what's on it, and you could build an indexer based on this.
Yep. Uh, hey, if you decide to test out Marlin, let us know. Write in the comments. Thanks for watching.
Yep. Thank you.
Bye.
Until next time.